Okay, guys, so I found a way to do this now by video lesson. So quickly, I'm running out of time here. Actually, I don't have more than a woman with a homozygous blood type A is married to a man with a heterozygous blood type B. What percent of their children will have blood type B? Can they have any children with blood type O? So first of all, we have to write down the, I need to make this finer. Oh goodness, cancel. So AA and BO, and we would do the Punnett square. So AABO, so it would be type AB, type AB, type AO, type, sorry, AB, AB, AO, and AO. Okay, so basically you only have, it says what percentage of their children will have blood type B. So 0% children will have type B blood. Okay. And then can they have any children with blood type O? So basically no. O is recessive. So you would basically, they would need both O's from, or two O's from both parents to be homozygous recessive. Okay, and that's not the case here. Okay, wealthy number, example 3, a wealthy elderly couple died together in an accident. Soon a man shows up to claim their fortune, stating that he is their only son who ran away from home when he was a boy. Hospital records show that the deceased couple were blood type AB and O. The man is blood type O. Do you think the man is an imposter? So again, we have to basically do the cross of the parents. So one parent was AB, the other parent blood type is O. We have to look at their, we have to do the Punnett square to find out what the possibility of having a type O child would be. So it would be the same, basically AO, BO, AO, BO. So there's 0 chance. So the genotype here, okay, is going to be 50% AO and 50% BO. There's 0% OO. So therefore, the man, sorry about that, the man must be an imposter, because if he's type O, he's definitely not their child. Example number 4. Okay, guys, so example number 4. There's 2 babies, type O, type A, and there's 2 couples, Mr. and Mrs. Smith, who are type AB and type B. Mr. Brown is type B and Mrs. Brown type B. Now the thing is, we don't know what type of genotype Mr. Brown or Mrs. Brown or Mrs. Smith are. They could be type BB, or they could be type BO. We don't know that, and we're trying to match these babies to these 2 couples. So the first thing that we would do is let's look at the first couple right here. We would need to do 2 different types of crosses to figure out which of theirs is, which baby is theirs. So we could do where we make Mrs. Smith, have her genotype be big B, big B. So we would fill in this Punnett square, and all the possible offspring would be 50% AB and 50% BB, which is 50% type AB and 50% type B. And neither of these babies are type AB or BB. So this is not going to work. I'm going to actually erase that to give myself some room. And the other cross that we can do now, we can make Mrs. Smith type BO, her genotype. Okay, so this is going to be Mr. Smith, and we're going to make Mrs. Smith type BO. So if you do that Punnett square and that cross, you have, here you go, you have one, we have one type A baby right there, which is this baby right here. So Mr. and Mrs. Smith equals, I'm just gonna, I know it doesn't equal, but they're the ones that are the parents of baby with type A. And then Mrs., I'm gonna erase that now too to make myself have more room here. Mr., obviously the other baby is Mr. and Mrs. Brown's, but if we were to figure that out with them, we could first of all do, I'm going to assume this is going to be, oops, let's just, the only way we should know this already, that the only way that we get a type O child is if we have two O's, because it's homozygous recessive. It's a recessive allele, so we need to have two O's in order to be type O. So I'm going to assume now then that Mr. Brown is BO and Miss Brown is BO, okay? And when we do the Punnett square, that's exactly, oops, that's exactly what we get. We get this one baby who is type A, and that baby belongs to Mr. and Mrs. Brown. Okay, and let's go back to the next page. Okay, how do we do this now? I think this is it. Oh yeah, blood, the blood sheets, the blood. I need to write on this as well, so let's download that. And let's see if I can, let's see if I can, guys, bear with me. There we go. And I don't know if I can make this any bigger. There. Okay, so blood type worksheet, fill in the blanks for each statement. So basically this is just a review of what I've been talking about so far. I'm going to try a different color. Okay, so each person basically in this blood has two genes that determine his or her blood type. And there are basically three different genes that combine two at a time to produce a certain blood type in a person. And the blood type that shows codominance is blood type AB, because blood type A is equally dominant to blood type B, or the A allele is codominant with the B allele. Neither one is more dominant than the other. And the blood type O is the recessive genotype. So there are 3 different genes for blood types are A, which is dominant, B, which is also dominant, A, B, which is codominant, and O, which is recessive. What type of blood or the phenotype results from the following genotype? So if you have AA, this is a genotype, you're going to have blood type A. And if you have AO, you're going to have blood type A. AB, blood type is going to be phenotypically AB. BB is going to be type B. BO is going to also be type B. And OO is going to be type O. Okay? Suppose a man marries a woman who has blood type AB. This man's blood type is, suppose a man marries a woman who has blood type AB. The man's blood type is, so we have to figure out the man's blood type. So you need to basically consider both genotypes of for blood type A. Okay, so we can do 2 crosses. So if we've got the woman who is AB, right, we are going to either make him AA, right, in this first case, and then in this case, in the second scenario, we can make him blood type O, okay? Because he is blood type A, we just don't know whether he's AA or AO. So we just do the Punnett squares here. AA, AB, AAAB, and over here it's AB, and he's going to be AO here. AA, AB, AO, BO. So what possible blood types will their children have? So here it's going to be 50% AA, 50% AB. Here it's going to be not 50%, it's going to be 25% AA and 25% B, 25% BO, and 25% AO, right? But phenotypically, that's the genotypes. Let's just write here, genotypes. Oh goodness, I'm going to run out of room. Phenotypes. It's going to be 50%. I have to erase some of this. I'm sorry, guys. 50% type A, and then 25% AB. I'm going to write it up here. So 50% type A and 25% type AB and 25% B. Okay? And there's going to be no percent, no chance of them having type O blood. Okay? And I'm going to ask that you try the others, and I will post the solutions for those. But just try those on the last page yourself. And if you have any questions or problems with any of this, please let me know, message me. I can call you guys back or set up a Google Meet, okay? Take care and have a wonderful day.